Welcome to B&W Insights. I'm your host, Mark Seifert. In today's episode, we talked to Megan Fox about PFAS. Coming from a municipality with PFAS, I understand the strife of operators, directors, and administrators. PFAS was manufactured in the 1940s, and only in the last 10 to 15 years have we really heard about it. It's in pots and pans, it's on weatherproof gear, and it's in firefighting foam. So we need to figure out a way to remove it. And we'll talk about that in today's episode with Megan Fox. Ready? Let's go. Megan, thank you for coming in today. How are you doing today?
I'm great. Thank you for having me.
So how long have you been at Baxter & Woodman?
Just over 5 years now.
Where do you come from? Straight out of college? What'd you do?
Straight out of college. I studied at the University of Illinois for 4 years, started at Baxter & Woodman the summer after I graduated, and last year I completed a master's degree online while I was working.
Holy cow, that is impressive. So how did you start diving into PFAS? What made you say, today I'm going to take on one of the world's most complex water issues and run with it?
It's really one of those cases where it fell into my lap. Somebody delegated a project to me that involved learning about the regulatory landscape around PFAS, and that was shortly after I started at Baxter & Woodman. And I really feel like I found my niche. I enjoyed the complexities of it. I enjoyed helping communities with a problem they really needed help solving. So I stuck with it ever since.
And that's awesome. You know, a few people we've talked to in a bunch of episodes here is they start working on these projects by happenstance. It's not that they go looking for them. It's not that they're, hunting out these complex issues, but you start with one project and then you continue working on it. And so PFAS chemicals were manufactured starting in the 40s. Why are we just starting to talk about it in the media, in engineering circles, in the water circles now? What changed in the last 10, 15, 20 years that has brought this to the front burner?
Right. More and more information has been coming out about PFAS, and we're still working on understanding all the potential health effects surrounding it. One of the big things that happened that really pushed regulations forward very, very quickly was actually the COVID-19 pandemic. One of the health effects that was discovered was a decreased immune response. So with the vaccines coming out for COVID, everybody was concerned that it could have led to a decreased immune response and made the pandemic worse than it already was. So in light of that, a lot of environmental groups and regulators became very concerned and really pushed those regulations forward.
You mentioned the big one, health effects.
Yes.
Health effects are usually the driving force of any regulation. What are the main health effects of PFAS?
Well, one thing I want to back up and explain is that PFAS is a family of chemicals. There's over 9,000 types of chemicals in the PFAS family, so we're still trying to understand the health effects of all of those. That's going to take a really long time to get a very good understanding of. Some of the main ones we understand now, though, and different health effects are associated with different chemicals. But generally, we're concerned with certain types of cancers. Developmental effects, so decreased infant birth rates is one, birth weights is one that has been a concern with that, and some blood health effects such as increased cholesterol, and then that decreased immune response.
So you mentioned those health effects, and, the first time I heard of PFAS, when I was working in a municipality, was actually the movie Dark Water. That I just stumbled across it. I was watching Netflix one night and I saw Dark Water. So I'm like, I'm gonna watch this, and I found out it's in drinking water. So I feel that kind of spurred a little bit, because obviously then the conversation started, hey, did you see this movie? And that was a little bit, but it's interesting to hear that the COVID-19 pandemic really pushed this forward. How does the PFAS get in our water supply? I know today with you, we're talking about drinking water. So how is it getting into our drinking water supply? Our drinking water, if you're at a shallow well, it has, natural ground filters. The deep wells are real deep, so there's a lot of filtration there. And then surface water, obviously, is probably the most prevalent to have PFAS in it, but what are the different ways we're getting PFAS in our water?
So PFAS is man-made. So that's why you're not seeing it as much in those deep aquifers, because it takes an extremely long time for things to get down to them. So that's why it's more prevalent in surface water that's open to the environment and those shallow wells that are under more of a direct influence. So the chemicals are made. They're put into many, many consumer products.
Give me some.
Yep. I'm talking about Teflon pans. That nonstick coating was originally made out of PFOS, which is one of the big types of PFAS we're concerned about. It's also in food packaging, a lot of fast food containers, since they're grease resistant. That's another chemical property of PFAS. It's in just about anything that's waterproof. And it's also fire resistant, so it's in a lot of firefighting foams and the materials that firefighters wear and use. So if you wash any of these things, it goes into the wastewater, down to the sewer, which eventually makes its way back into the environment and then gets into our drinking water back down the line.
Okay. So obviously we don't want it in our water. It's man-made. It's potential health effects. How do we remove it? What process are out there? In doing some of my research, there's a few different ways, but give me some ideas on some of the main ways that we're removing it from potable water.
I'll start off with it's not easy. There's
probably not cheap.
Definitely not cheap. So there are a couple ways that are considered recommended ways of removing PFAS. The first one is granular activated carbon. That's similar to what you would see in like a Brita filter. Then there's anion exchange, which is a specific resin, and it works similarly to a water softener, but you need to select a specific resin that will remove PFAS. And then the other one is reverse osmosis, which is a kind of filter that has the tiniest little holes in it that PFAS cannot get through.
So before I dive into some of the individual filters, because I find it amazing that we're using filters and then they're going to have to get thrown away because filters have to get thrown away. But I know the IEPA did statewide testing for PFAS. Are municipalities now required to continue testing? Is everyone or just those who had hits?
Yes. So municipalities should be testing. That helps them get an understanding of what they're going to need to do. On April 26th of this year, the U.S. EPA, so nationwide, released maximum contaminant levels, and there is a testing component to that. So by April 26th of 2027, every municipality is going to need to test for at least 6 kinds of PFAS and get an understanding of where they are before those regulations fully go into place.
Well, that's awesome that municipalities have to continue testing, because as the PFAS continues to move throughout groundwater, new places are going to be knowing that they have it. Getting back into the filters, every filter that you use has an end of life, whether it's the GAC, the granular activated carbon, or the reverse osmosis, or whatever it is. What are some of the problems associated when these filters reach their end of life? Because that's the O&M cost, the replacement cost. I know the money component to PFAS is going to be astronomical, but what's then, after the initial capital cost, what's that down the road cost looking like? How long are these going to last? Does anybody even know yet?
Right. So with traditional granular activated carbon and anion exchange, you can normally do something where you recharge the resin. It's up and coming to be able to do that when it comes to PFAS concerns, but because it is something that is toxic and persists in the environment, it's a little bit more expensive to do. And right now we're seeing more communities opt for disposal of that resin, which increased the cost of replacement. Hopefully more companies down the line start innovating and finding ways to do that recharge so we can recycle our resin and our GAC, but we're still seeing that up and coming.
So when a municipality gets rid of the GAC, gets rid of the resin, I assume it's going to a landfill where then it still has the potential to leach back into the certain drinking water, so it's a never-ending cycle, correct?
Correct.
You mentioned something that is going to take me into my next topic of innovation. You've been working on this for a few years now. What innovation have you seen that you've just said, man, this is cool. This is going to be a game changer. What's going on in the world of innovation for PFAS and PFAS removal?
Mm-hmm. There are a lot of new innovations coming out of universities. I'll be really excited when I start to see those coming more to a full scale. I think the one that is starting to get there is something called foam fractionation. So this gets into a little bit of the nerdy chemistry of PFAS, where it has a polar and a non-polar end, sort of like soap. So part of it likes to stick to water and part of it likes to stick to air. So PFAS really likes to live on the surface of water. So what they do is they bubble air through water, and it collects the PFAS and creates this very heavily concentrated foam on the top of the water. And then they can take that concentrated foam and incinerate that, which actually destroys the PFAS, rather than just collecting it and disposing of it.
And that right now is just I'm assuming on a pilot study somewhere, but...
Yep, more on the pilot study phase. Very exciting for the future, but
and I think that there's going to have to be some major innovations because municipalities are not going to be able to continue going down the same path of this cycle. Somebody's going to figure out how to get rid of it. You mentioned parts per trillion, and I think that number's just incredible. You know, when I first got into the industry, it was parts per million, parts per billion sometimes. Now we're talking at the parts per trillion level, and something I once heard was parts per trillion, 1 part per trillion is like 3 foot from here to the moon. Mm-hmm. So we're looking at these at the nano level, and it's amazing that we're looking at 2 parts per trillion. That talks about some of the innovation in our testing as well, correct?
Yes. Yeah, there's been a lot of innovation in testing specifically for PFAS because being able to test down to this low of a level is insane. It is a drop of water in a Olympic-sized swimming pool.
I love it. I love the analogies. It really makes it able for people who are listening to understand how minute this is, but how big of a problem it's causing. Does every municipality have PFAS, or some not have it, or where are we at across the state? And across the country, really, because if we look at, obviously we have the Illinois with PFAS, but since this is in more, firefighting foam and sticking pans and weatherproof, is this a nationwide issue we're looking at? And does every single municipality every single water supply across the country foreseeably going to be facing this?
I'll say yes, it is nationwide, but there are definitely hot spots. So areas where there's an airport where they've had to use that firefighting foam. Mm-hmm. Not every fire has to be fought with a specific firefighting foam, but jet fuel specifically is something that does need it to put it out. So airports, military bases are common sites where we see a lot of PFAS contamination in the groundwater. There's also certain manufacturers that use it. So around industrial areas, we might be seeing more of that PFAS. So no, not every community currently has PFAS at detectable levels, but everybody should be at least looking out for it because we know with Phaeton transport that things can get into our groundwater and spread.
Federal regulations, state regulations, everybody's coming out, everybody's talking about it. Give me a couple minutes on what are the federal regulations saying right now? Are there any updates coming? Have they mentioned updates? Where are we at in the federal regulation land?
That is a confusing answer because we're in a couple different places. Because like I said, there's 9,000 different types of PFAS. So the big one is that for 6 of those types of PFAS, we have a enforceable maximum contaminant level that came out earlier this year that I mentioned before. So that is for PFOA and PFOS. We're looking at 4.0 parts per trillion as the limit. And then for PFHXS, PFNA, and then something called Gen X chemicals, which was kind of a replacement for PFOA and PFOS, we're looking at 10 parts per trillion.
Okay.
And then we have something called a health index, which is brand new to the world of water treatment and maximum contaminant levels. It has been used in remediation in the past.
We look at all these numbers and trying to even remember all these acronyms is, crazy. And moving towards, paying for this, municipalities aren't the ones who manufactured PFAS.
Correct.
So is there going to be help paying to remediate it? Is there federal funding? What's coming down the funding pipeline to help with PFAS remediation and PFAS removal?
Yes, so there was money set aside in the bipartisan infrastructure law specifically for emerging contaminants. Now, that's not just PFAS, but PFAS is a large chunk of that and probably the hottest emerging contaminant we're dealing with right now. The other route that some municipalities have chosen to go, there have been class action lawsuits against the original manufacturers. So there have been 2 of those that have been in process fairly recently. I believe the deadlines to apply to those have passed at this point, but some communities have been applying for that money. They haven't seen it yet. They're expecting it'll take like 3 years to come out.
So there's different ways different municipalities are trying to fund this, and inevitably it's going to go back on the back of the ratepayers eventually, because they're going to have to repay loans or repay funding. So, what can communities begin to do if they're navigating PFAS? They're just finding out they had it in the last couple of years. What can they do to really navigate this landscape?
So what I would first recommend is, if you haven't already tested, definitely test to understand where you are at. The next step would be to inform yourself, because it's out there in the communities. Environmental groups are asking these questions of their elected representatives and their water municipalities, all of that. So you should be the person that is most informed on PFAS in your community so that they can look to you as a guiding light. Because they're panicking, you don't want to be panicking yourself.
Awesome. Well, that's some great advice for municipalities. And I want to thank you for coming down here today. Great topic. Super awesome to hear about how you've been so invested into PFAS. I want to thank you for your time today.
Thank you.
Well, that was an interesting conversation with Megan Fox and learning all about PFAS and how we're trying to remove it from our water system. Thank you for your time today, and let's see what's on the menu next.